Two of the most talked about structured parsing vision models of 2026 are dots.ocr and PaddleOCR-VL. Both promise to turn a document not just into text, but into structure. Tables, key value pairs, layout. So I put them head to head on my 8 gig laptop on the same documents and measured accuracy, memory, and speed. But the most interesting finding wasn't any single number. It was how hard these two would even run in the same place. Here's the document both models face. A sample vendor invoice with a header, a built-to block, a line item table, and totals. The interesting part for dots.ocr is that table, because a real structured parsing model shouldn't just read the cells. It should preserve which value belongs in which column. This same invoice goes through every model, so it's an even test. And here's the code for dots.ocr. You load it with trust remote code on transformers 451 and bfloat16 with SDPA attention, one quirk to know. You pop that in token type its field before generating, or it throws an error. Then you call generate. Dots.ocr is a 3 billion parameter model built specifically for structured document parsing, and that focus shows up directly in what it returns. And this is dots.ocr's real output. Look closely. It didn't return flat text, it returned a structured HTML table. Every row and every cell. Description, quantity, unit price, amount. Wrapped in proper table markup with the total 23, 21, 42 correct. That structure is the whole point. It means a downstream system can consume the table directly without guessing where one column ends and the next begins. Here's the wall I hit almost immediately. Dependency hell. Dots.ocr's custom code is pinned to transformers 451, while PaddleOCR-VL needs transformers 5.x for its masking utilities. Those two versions are mutually exclusive. Install one and the other breaks on import. There is no single environment where both run. This is the recurring reality of research-grade local models. They're each pinned to a moment in time, and getting two of them to coexist is often impossible. So I couldn't benchmark them side by side in one process. I had to run each in its own pinned environment and compare the results afterward. And they can't co-fit on the card either. Dots.ocr is a 3 billion parameter model that sits near the top of the 8 gig budget, so there's no room to load a second model beside it. Every comparison here is sequential, one model at a time, which is exactly how you'd have to deploy them in practice. On raw accuracy, both models are strong. On my 4 test documents, they read the text essentially correctly. The invoice, the 2-column article, the formula page, the multilingual page. Dots.ocr, being the larger 3 billion model, has a slight edge on the hardest structured cases, and crucially, it returns the invoice table as clean structured HTML rather than flat text. PaddleOCR-VL at 900 million parameters is impressively capable for its size, but its output is flatter, line by line. On memory, the size difference shows. Dots.ocr, at 3 billion parameters in bfloat16, sits at around 7.9 gigs of VRAM, right at the edge of the 8 gig card, with essentially no headroom. PaddleOCR-VL at 900 million is far lighter and leaves comfortable room to spare. If your only constraint were the card, the smaller model looks attractive, but memory isn't the whole story, and the next number is where it gets decisive. Because here's the twist that a spec sheet never shows. Runtime. On my setup, PaddleOCR-VL through native transformers was pathologically slow, taking on the order of 270 seconds per page, over 4 minutes for a single document. Dots.ocr, despite being the larger model, ran dramatically faster. So the smaller, lighter model was by far the slower one in practice. That gap is an artifact of the serving path, not the architecture, but it's exactly the kind of thing that decides a real deployment. So the verdict for the 8 gig laptop, dots.ocr is the one I'd reach for. It's heavier on VRAM, but it returns genuinely structured output and runs at a usable speed, while PaddleOCR-VL, though lighter and capable, was crippled by its runtime on this setup. But the bigger lesson is the one from the dependency wall. With local structured parsing models, the model fitting is rarely the hard part. The environment, the versions, and the serving path are what actually decide whether you can ship it. That's dots.ocr versus PaddleOCR-VL, measured on real hardware rather than a benchmark table. Both are impressive models, and both are worth watching, but on an 8 gig Windows laptop today, dots.ocr is the more practical choice. The full numbers and the exact environment fixes are in the description. I am Aditya. See you in the next one.